So we're going to take a look at 6.2, properties of parallelograms in this section. And our question for our math humor of the day, what do you call an urgent message across a parallel network?
That must be a parallelogram.
Oh. All right, so take a look at a quadrilateral. What is a quadrilateral? Well, a quadrilateral is a polygon, so we're talking about polygons in this chapter, and it has 4 sides. That's literally what a quadrilateral is. Now, we already know from section 6.1 that the sum of the measures of the interior angles of a quadrilateral is 360 degrees. So instead of doing that long formula of s equals n minus 2 times 180 every single time, if you just remember the quadrilateral has 360 degrees, you are set. Now, there are specific types of quadrilaterals, and the first type that we're going to talk about is called a parallelogram. And notice the root word in that is parallel. I think that's root word. I'm not quite sure. Not an English teacher, so don't call me out on it. So parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So if I'm taking a look, this is kind of freaked out slightly here. If you're looking at this, this parallelogram symbol should really be over here. So that's what I'm going to do. I'm going to draw it over here, and it says, well, that's bad. But anywho, the parallelogram, if I tell you you have a parallelogram, if you have a parallelogram, then you know opposite sides are parallel. So that's really the first property of a parallelogram. It comes from the definition. So in our diagram down here, we know that the opposite sides of VK and RN are parallel. VK is parallel to RN. And we also know that VR and KN are parallel. So both pairs of opposite sides are parallel. Now, when we're working with this parallelogram VK and R, what we have is, I basically just told you the name. It's a 4-sided figure, and when you name any polygon, you have to start off with one vertex and either go clockwise or counterclockwise. So if I choose to say, let's say I start off with R, okay, and I choose to go clockwise, I would name this parallelogram R, V, K, N. I can't jump around. I can't say R, V, N, K. I have to keep it in one continuous motion. So when I name this, I'm going to put the little parallelogram symbol down, and I will say R, V, K, N. I could also name it parallelogram NKVR. Any of those are going to work as long as you're not jumping around. Now, when we talk about the opposite sides of a parallelogram, the opposite sides are the sides that are across from each other. So we know that segment VR and segment KN would be one pair of opposite sides, and the other pair of opposite sides would be VK and RN. So we have 2 pairs of opposite sides. Consecutive sides are the sides that come one after the other. So if I said segment VR, a consecutive side that would be connected would be segment RN. So I'm going to write VR and RN. And we'll also do maybe, what about RN? And the next consecutive side I would have with RN would be a KN. So I'm going to write and KN. And then I'll have 2 more pairs, KN and VK. And then the last one, VK and RV. And remember, when you name segments, you can name them either as like RV or VR. They both mean the same. Now, opposite angles are the angles that are across from each other. So angle R here, its opposite angle would be angle K. And angle V, its opposite angle would be angle N. So I'm going to go ahead and now write those down. So angle R and angle K. And then the other set was angle V and angle N. Consecutive angles are the angles that come one right after the other. So if you remember our alternate interior, alternate exterior, same side C's, and supplementary, R supplementary, and then what was it? Corresponding, that's what it was. Corresponding angles. The same side C angles are the same side interior, they're consecutive, okay? The consecutive interior angles. So really I'm looking for the ones that come one after the other. They make the C's. So angle R and angle N would be a pair, angle N and angle K. Angle K and angle V, and then angle V and angle R. And all I'm going to do is list those. So angle V and angle R, angle R, and angle N, angle N, and angle K, and then the last one, angle K, and angle V. Those are my pairs of consecutive angles. Lastly, the diagonals of the parallelograms are those segments that connect the vertices that are not connecting the sides. So I've got from R to K, that would be one diagonal, and from V to N, that would be another diagonal. So my two diagonals would be RK, that segment, oof, the K, and segment VN. So in addition to knowing that in a parallelogram, both pairs of opposite sides are parallel, we also know that both pairs of opposite sides should be congruent. So if I tell you you have a parallelogram, not only can you tell me opposite sides are parallel, you can also tell me that opposite sides are congruent. So in this case, segment AB is going to be congruent to segment CD, and BC would be congruent to AD. There are three additional theorems that go along with parallelograms. In addition to opposite sides being parallel and opposite sides being congruent, we know that if I have a parallelogram, then opposite angles are going to be congruent. So angle A and angle C would be congruent, and angle B and angle D are congruent. In addition to that, we also know that consecutive angles are supplementary. It makes sense because if the lines are parallel, if the opposite sides are parallel, then same side C's would be supplementary. So if I'm talking about angle B and angle A, they would be supplementary. Angle A and angle D, supplementary. D and C, and then C and B. Those are all the pairs of supplementary angles, meaning they would add up to a measure of 180 degrees. The last property of parallelograms that you have to know, there's 5 in total, just to let you know. The last property, if I tell you you have a parallelogram, then you automatically know that the diagonals bisect each other. So if they bisect each other, that means AZ would be congruent to ZC, and BZ would be congruent to ZD. So the 5 properties, in recap, if you have a parallelogram, you know opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side C's are supplementary, and diagonals bisect each other. Those are the 5 properties for parallelograms. So if we utilize those parallelograms, what we want to do here is we want to take a look at the parallelogram FMVH, and they tell me it is indeed a parallelogram. The other thing they tell me is that FM is 24, they tell me MD is 15, and then they say MV is 16, and FD is 10. The only problem I'm going to have with this is you do not see any letters on the diagram, so I need to fill those in. So we're going to start off with F here. We're going to say this is M, V, and this is H, and then we'll stick D right in the middle, okay? Now, label your diagram, label your diagram, label your diagram. Can't say that enough. So if they're telling me FM is 24, I'm going to put that up here for FM. Then they tell me that MD, this segment right here, is 15, so we'll go ahead and I'll label that with a 15. They say that MV was 16, so we'll go ahead and put a 16 down for MV. And then the last one, FD, they told us FD right here was 10. So I'm going to go ahead and label that. Now, using that information, I should be able to answer all of these. So if I look at FH, FH is this side right here. I know then that the side opposite sides are congruent in a parallelogram. MV should be the same measurement, so FH should also be 16. How about you take a look at the other 3 and try to fill those out on your own? Pause the video here, and then when you come back, I'll have the answers written in for you. So if we take a look at the distance for HV, we notice that HV is the side opposite of our FM. Therefore, they should have the same exact distance, and HV will be our 24. MH is slightly different, though, because for MD, we know that segment is 15, and with parallelograms, the diagonals bisect each other, so we know HD should also be 15, and if we add them up, we end up getting 30. The last one for DV is this segment right here, and for DV, since we know that FD was 10, we also know that DV should be 10. So in this example, we're taking a look at parallelogram ABCD. And the capital D looking things are actually supposed to be angle symbols. So if you see this and you're wondering what are those D's, they're really angle symbols. It didn't transfer over. So I'm going to write them over right now. So what we're doing here is we're taking a look at the angles, and they've given me several angles that I can label in my diagram, and we want to kind of fill out the diagram and answer the following angle measures. So the first angle they give me is angle DAE. So DAE is this angle right here, so I'm going to go ahead and label that with a 70. And then the next one they said is angle ABC. So ABC is this whole entire angle, and since it's the whole angle on the outside, I'm going to label that with a 50. The next angle is BEC. So BEC is the interior angle here. We're going to label that with an 80 degrees. So once I've got all those labeled, that's really all I need to be able to figure out the missing angle degree measures. Now, when working with a problem like this, it's usually easier if I go ahead and label the entire diagram and then try to use that to fill in the answers for the angles. So what I'm going to do is I'm going to take a look at some of the angles here and see if we can't figure those out. Since we know that angle ABC is 50, we know that in a parallelogram, consecutive angles are supplementary. So that would mean that angle DCB should add up with this angle right here to 180 degrees. So if the one we have here is 50, that means DCB should end up being 130 because they have to add up to 180 degrees. Also, we know that opposite angles in a parallelogram are congruent. So if angle B here is 50 degrees, the whole angle, that means angle D, the whole angle down here, should also be 50 degrees. I also know that angle A and angle C are opposite angles, so those should be 130 degrees each. Now that gives us a good chunk of information to be able to figure out some of the other missing angles. If I take a look, I know that this angle here is 70 degrees, so then angle DAB, the whole angle was 130. If the whole angle is 130 and I already have 70 of them taken away, I know that the remaining portion of that angle should be 60 degrees. Now, if I look at alternate interior angles, we dealt with that in chapter 4. Alternate interior angles are the ones that make the letter Z's. So if I'm working with, say, angle BAC, that's a 60-degree angle, and angle DCA, that should also be a 60-degree angle because they're alternate interior. I'm going to do the same exact thing with angle DAE and angle BCE. Those are also alternate interior, so I would know then that BCE should be 70 degrees. Last one that's really going to help me out with this is I know there's 180 degrees in a triangle. And if I'm working with a triangle here, and I currently have 80 and 70 degrees, if I add those two, I'm going to get 150 degrees. 150 degrees away from 180 degrees in a triangle ends up leaving me with a 30-degree angle. So this is going to be a 30-degree angle here. And since the whole angle was 50 degrees, and this is 30 as a part, the other part has to be 20. Using alternate interior angles, I can find out the measurement of the two corner angles by D, and this will be 20, and that'll be a 30. Lastly, let's talk about the interior angles here around E. If this angle is 80, I know this angle and 80 are a linear pair, so they should add up to 180 degrees. So the angle here should be 100 degrees. I'm going to go ahead and label that as 100. And then vertical angles are in play. So the vertical angle should be congruent. That means all of those angles are filled in. Why don't you go ahead and take a minute here to fill in the missing angles down below, and then pause the video. I'll fill them in, and when you start the video again, maybe we can double check it and make sure we have the same answers. So I've written down all the angle degree measurements. Go ahead and take a minute and double check them with yours and see if you've got the same answers. If you don't, why don't you go ahead and star them, and then make sure to ask me in class tomorrow. All right, in this example, I'm giving you parallelogram ABCD, and I'm telling you a couple things about some angles and segments. And what we have to do is we have to find out what the measurements are for X and Y, so the values for those. First off, I notice I don't have a diagram, and if I don't have a diagram, the best route to start the problem is to go ahead and draw a diagram out yourself. So you want to make sure that you start off with your parallelogram, and when you label, it's really important that you label it starting in one corner and either go clockwise or counterclockwise, but you can't jump around. So what I'm going to do is I'm going to start in the upper left-hand corner with my A, and I'm going to choose to go clockwise. So I have A, B, C, and then D. Next, I'm going to go ahead and label with the information they gave me. So they said angle A was 3x. I'm going to put a 3x down in there. And then they said angle B was 4x plus 40. Next, they told me that AB, that segment, was 5y minus 3, and CD was 2y plus 9. Now that I've got my diagram labeled, I can try to set up a couple equations to help me solve for my x's and y's. Let's go ahead and take a look at x's first. The ones that are dealing with x's are my angles. Now I notice that these two angles, A and B, are not opposite angles, but rather consecutive angles. And according to parallelograms, consecutive angles are supplementary. So we're going to go ahead and take the 3x and the 4x plus 40, we'll add them up, and we'll set it equal to 180. So putting my like terms together, I get 7x plus 40 equals 180. If I subtract my 40, I get 7x equals 140, meaning x will be 20. So at least I found out what my x is. The next thing I have to do is solve for y. The two measurements that deal with y are the ones for the sides that are opposite of each other. In a parallelogram, opposite sides are congruent. So I would say that 5y minus 3 should equal 2y plus 9. So if I subtract 2y from both sides, I get 3y minus 3 equals 9. Add 3, 3y equals 12, meaning my y should end up equaling 4. Since the problem only asked for us to solve for the values of x and y, you're done as soon as you box those answers, and you don't have to plug anything back in. The last problem in this set of notes asks us again to find out what the values of x and y are, assuming that this is a parallelogram. So they're giving me a parallelogram, and those 5 properties for parallelograms kick in. We know opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side c's are supplementary, and diagonals bisect each other. So in this instance, we're dealing with opposite sides. And we're also talking about opposite sides being congruent. So what I would probably do is set up an equation. Maybe I take a look at these two sides first. So if I say 2y equals 5x minus 28, my best route with this is to probably take this equation, since it's got two variables in it, and I know that the next equation I'd be working with, the 2x minus y would equal 10, that would also have two variables in it. So why don't I go ahead and write that one down over here too. 2x minus y equals 10. So I've got my two equations from the opposite sides being congruent. Now you can either try to line them up and do an elimination, because with two variables you need two equations. So either you're going to eliminate variables, or what I'm going to do in this case is I'm going to use substitution. So I'm going to take one of these equations, I'm going to solve it for a variable and shove it in the other one. The easiest one to solve for, I don't know. I'm probably going to use the 2x minus y equals 10. That's probably easier because the y doesn't have any numbers in front of it. So let's go ahead and get the y by itself in this one. And to do that, I'm going to go ahead and subtract 2x from both sides. So I get negative y equals a negative 2x plus 10. And the last thing is to get the y by itself, I'm going to go ahead and divide by a negative 1. So when I divide by a negative 1, everything changes symbol-wise. So I get y equals 2x minus 10. Now that I have that, I'm going to take what y is, and I'm going to throw it in to the other equation. And when you throw it in, you're substituting that in. So I've got 2x minus 10 goes in for every y I see. When I throw it in for the y's, notice all the y's are gone now, and all I have are x's left, which means now I can solve for my x value. So if I distribute the 2, I get 4x minus 20 equals 5x minus 28. I'm going to go ahead and subtract 4x from both sides, so I get negative 20 equals x minus 28. Add the 28 to both sides, I get x is 8. So now that I have what my x is, I can also find out what my y is by taking that and throwing it back into the one that I solved for y. So I would know that y would equal 2 times 8 minus 10, which means y would equal 16 minus 10, or y would equal 6. And that's all I have to do. A good way of doing this to make sure that you check, so go ahead and plug those values back in and ensure that the sides are indeed congruent. If you have any questions, make sure that you write them down and you ask me in class tomorrow. Otherwise, I'll see you tomorrow.